Hello, everyone. We are live, and our next session is Offensive Security Engineering, why your Tara needs a reality check. Threat analysis and risk assessment is essential to automotive cybersecurity, but many assessments rely on theoretical attacker models rather than a real-world experience. The following talk highlights gaps in current practices and demonstrates the value of integrating offensive security expertise to produce realistic and actionable risk assessment. Joining us on stage is Yanis Kelter, Head of Cybersecurity at Holon, with over a decade of experience in product, cloud, and application security. Please welcome Yanis on the stage.
Yeah, thanks and welcome as well. So I hope you can hear and see me. If that works, then welcome to the call and welcome to the talk. Bear with me, my voice is not the best. I've caught a bad flu in the last days, so I'm still recovering. So it might be necessary to drink something while I'm talking. Also, presentations, please don't expect a marketing presentation. I'm not a marketing guy at all. Like, I'm extremely bad at making presentations. So the largest part of my presentation will be verbal information that you will receive from me. It's also intended to be a document, like you can also read it. And I really like when you have the possibility to at least understand what the presentation was about later without having to, I don't know, guess what was meant. So I know it's bad practice, but I put a lot of text in my presentations, but don't worry about it. I will explain everything in detail. Time schedule is roughly 30 minutes. First of all, just quickly say a few words about myself, and then we would dive into the topic already, and then we still have a lot of time to ask some questions. Feel free to use the question and answers function here to already ask your questions during the call. So a few words about myself. I'm Yanis Kelter. I'm from Germany. I'm currently working as a head of cybersecurity for Holon. We are a small OEM from northern Germany who is producing an autonomous electric bus. And what we are currently doing is, or the current challenge that we have is really just bringing the first autonomous mover on the market in Germany, not only Germany, but also in the United States. So United States launch will be first. And my core task is to ensure that the entire thing is not getting hacked, neither is the cloud infrastructure behind it. Before that, I was working at Continental and Robert Bosch and some other companies for quite some years. So I have quite some tenure in the automotive cybersecurity business. My LinkedIn is in my profile, so if you want to add me for whatever reason, just follow that link. And other than that, I would just jump right into the topic and tell you a little bit why this actually is a topic that drives me a lot. So when we made first contact with the ISO 21434, and I think it was in 2016, 2017, around the corner, it was already clear that the 21434 would be kind of a bastard child of different already existing standards. And what I observed in the last few years is that there are some crucial problems with the 21434 and how it is applied. And that's one of the reasons why there are so many findings in the cybersecurity type approval, because while a lot of the 21434 is actually applied on the systems engineering level, the validation level looks a lot different. And this is just my view on the topic. And I want to give you guys a good suggestion as to how we can actually improve the process that has to do with the offensive side of cybersecurity, bringing a little bit more of the penetration testing into the regular systems engineering for cybersecurity. But I'm also giving a formal explanation of why that is actually a good idea, and not just saying, okay, we just need to do more penetration testing in the first place. So first of all, target audience should be pretty much clear. I hope you can see the slides, by the way. Otherwise, I have to refresh something. So everybody who has ever written a Tara is very much welcome here. Also, if you have never worked with Taras, although it will be a little bit confusing to you then, and anybody who's actually involved in the automotive cybersecurity world is, of course, also welcome to join and ask questions about it. I think everybody in this room knows what a Tara is, at least I hope so. It's one of the core documents of 21434. Essentially, it's a pipeline. We start with the assets, we derive some risks, some threats, and in the end, we have a prioritized list of things that can go wrong based on cybersecurity attacks. And then that allows us to choose, for example, controls to mitigate these risks. And we can also derive claims, which are then used in another part of the vehicle, for example, or in another component that is maybe in a different location. Usually the TARA is conducted in the way I just described. We have the assets first, then we perform some form of threat modeling to derive threats. We have damage scenarios, which mostly they come from safety, but there's some additional ones on top. And then we have the very tricky step, which in my opinion is like the hard piece of the TARA, and that is the conclusion which attack steps are necessary to realize a threat, what is the attack feasibility of these attack steps, and then the calculation of the risks for these steps. And what we will be mostly talking about is this area, right? So talking about how does this risk analysis actually work, and how do we evaluate what is actually a different attack. The last steps are actually quite simple because managing the risk is then quite trivial. For every risk, you pick a countermeasure, or you just accept the risk, or you transfer the risk, then you're good to go, right? This is how a standard 21434 TARA is being done. Looking into the logic, how the feasibility of an attack is actually derived, we usually start with the attack paths. And the attack paths are a really good concept, and there's not a lot we would need to change about this, right? They are based on Bruce Schneier's attack trees, so this is really, really established. I think that everybody here has at least seen an attack path in the past already, and they are already quite interesting if you look at them in detail, because you will see that the attack path is, unlike in safety, where you have a risk evaluation as well, but the attack path is almost like a test description that you need to perform in order to validate the attack, right? So it contains a lot of low-level information. That's also why attack paths are such a pain in the ass, because it's really hard to automate. And in many cases, it's just a wild combination of either like diagrams that are being drawn, or there is some kind of very ugly Excel magic that you can do to imitate it. There's also tools on the market that you can buy that do this, but it's really important that the attack path is one of the centerpieces. And every step in this attack path is then traversed, and you usually use a logical XOR to check what is the easiest way to traverse the attack path, and then you know how difficult it essentially is to actually realize the threat. And for that information, you need to know the core element number 2, which is the attack feasibility rating, right? So you need to ask yourself, how difficult is it to perform a specific step in the attack? And now it becomes really interesting, because if you look at the rating methods that the 21434 asks for, you see that the standard actually mentions three of them. So one is the attack potential based approach, one is the CVSS based approach, and one is the attack vector based approach. I actually thought about like making a little poll here, but I don't want to overblow the time schedule. But I'm quite confident to say that about 90% of the TARAs that I have seen in my life are using the attack potential based approach. And the main reason for that is there's a variety of reasons why we have different approaches to actually find out how difficult an attack is. We see that CVSS, for example, which is really good. The only issue with it is that it's tied to classical IT systems, and it's primarily good for specific vulnerabilities, very similar to CVEs in a way, but it's really difficult to model abstract threats with CVSS, especially since it's usually not made to be used in an embedded system. And the attack vector is honestly, if you look into the standard, it's kind of weird, because the attack vector is really just one abstraction that says it's not we are just looking at how difficult it is to actually achieve the attack on a very high level. It really just has, it's almost as coarse as just using the attack feasibility directly. And then the attack potential is basically the only thing that's left, because that's also the only thing that actually gets explained in the 21434. So if you start out as a cybersecurity engineer, you basically are bound to go with the attack potential anyway. It also makes sense because that's what I'm going to explain in the next minutes. It's also quite industry proven, so it's not that it's a bad solution. It just needs to be applied correctly. Um, so attack potential approach. I think most of you know this. We are taking into account 5 different domains. So elapsed time, expertise, knowledge, window of opportunity, and then we have equipment. And then for each of these, there's a table. We make some assumptions in general, and then we know what the attack feasibility is. Now, everybody who knows this approach knows how difficult this is. If you sit there and now you have to evaluate, how long does it actually take? Like, does it take 1 day? Does it take 2 days? How many experts do I need? It's really hard, especially for juniors. It's really difficult, but it's one of the core parts of the entire Tara. So it's, I think, in my opinion, a very good question to ask: where does this come from? And the answer is quite simple. This is not a reinvention, but this is really something that comes from a different standard, and that is the ISO 15408, which I think very few people among you know. So it is primarily used to assess the cybersecurity of IT or IT security products. We are talking about smart cards or routers, firewalls, special security appliances such as HSMs, for example, that are used in the industry. Um, they are using it, and it's primarily a very own standard with a very niche set of users and evaluators. And the interesting thing is that this was decided to be used for the 21434 as one of the absolute most important inputs. And we will see in the next minutes how that actually translates and why it had such a big effect on the attack potential. So if you look at the common criteria, we see, as I said already, it's made to rate IT products in general, not embedded products, not vehicles in general, but IT products. So there's a 7-step scale, which is about the evaluation assurance level. So the core idea is, because common criteria is an evaluation standard, it is not an engineering standard. And on these levels from EAL1 to EAL7, there's an increase in rigor and depth of the evaluation activities. And also, the common criteria already mentions the attack path as one of the things that constituted the attacks, and then the attack potential. And it's used in the exact same way as it is in the 21434. And as a last point that I mentioned in here, the cybersecurity assurance levels that you can find in the 21434, it also comes directly from common criteria. It's actually just an abstraction of the evaluation assurance levels that are in common criteria. So yeah, basically just copy pasted it. Each of the evaluation assurance levels has a VAN level. So that's essentially the assessment level at which the vulnerability would be actually checked. And as you can see in this list, I'm not going to go through all of them, but the higher the EAL is, the higher the VAN is, and the higher the VAN, the more rigorous testing is required. But what you will see is that even for EAL1 or EAL2, there is already pen testing done to show that the resistance against this attack potential is actually there. So some of you might already guess where I'm targeting here, because you can see that the entire logic with common criteria is to perform an analysis and then to validate this analysis in a very rigorous way. So just for your understanding, EAL7 is really rare. It takes a lot of work to get an EAL7 certification for common criteria. And it doesn't even matter what kind of EAL level we would assume for an automotive product. All of them require some form of validation in this case. So the entire evaluation process looks like we have a target of evaluation, and we try, does it actually resist attacks that the required attack potential is indicating for each attack steps. So they start with the security claims, they list an attack path, then they prioritize it by the assumed attack potential, and then they pen test the selected attack paths. So there's an independent evaluator testing. If the exploit works, so if the pen test produces a positive result, then the attack potential needs to be justified against the EAL requirement. This sounds a little bit complicated, but for example, if you have a master pen tester who manages to break the security mechanism, but the EAL level is kind of low because the assumed security is kind of low, then it's not even a problem if the pen tester was able to break the system. It's really important just to check if what was assumed in the analysis is matching with what was found later. And if there was a master pen tester who conducted this, then it is not refuting the original claim that the system needs to be hacked by someone who is a master pen tester. So very much important is that the core idea is that we use pen testing in the proof step. That is essentially our validation for the entire assumptions that we have made before. And the attack potential in common criteria is used very much similar to the 21434. You identify the threat scenarios for each the items. They are called differently. They are called attack scenarios, but it's not important. Then there's attack paths that are being sketched. There is a first attack potential rating. Then there's penetration testing, and then you know basically if it needs to be adjusted or not. This is a major difference between the 21434 and common criteria. And then if we look at the 21434, what happens there is we will see that if we just look at the standard, there's two types of testing that are more or less mandatory. And one is the requirements-based testing. That is nothing new. If you work in automotive, if you have ever had an ASPICE conforming product in your past, you will know that requirements have to be tested. They have an acceptance criteria, and there's a test description. That's it. Now, everybody here who works in cybersecurity knows that positive testing is really difficult with cybersecurity because a positive test is usually a feature test. So I don't know, the startup time needs to be 50 milliseconds. That is a positive feature. I basically just start the ECU and I see if it's up in 50 milliseconds, and if it does, then the test is checked. That's it. Now, for cybersecurity, that's extremely difficult because SecOC, for example, protects message integrity, but I can only test if nothing breaks, but it's really hard to test all of the systems, all of the scenarios where it would not break and where, for example, a manipulation would be undetected, right? So that's the second point, the cybersecurity goal validation. So I have maybe the cybersecurity goal that I want to have integrity on the message bus, and that is negative testing. So I basically try to break the cybersecurity goals. Maybe I can use a SecOC message without a signature, and it would still be accepted by the ComStack. In that case, I have shown that there is a negative test case scenario which will actually break the cybersecurity goal. So I would not necessarily call this penetration testing, but it is something that is already in the line of penetration testing. And both of these work in general in the automotive industry as an accepted criteria. And the only issue with them is that it doesn't actually validate any of the assumptions that were made in the TARA. So it's good to know, right? At the end of the day, you know that the cybersecurity goals hold, but you have absolutely zero assurance that your assessment that you did in the TARA is actually correct. And the same is true for if you are an OEM and your supplier gives you a TARA, you have no way to confirm that this assessment is actually true unless you test it manually. So the core issue, if we look at the common criteria and the 21434, is that the validation is very different. We have the attack potential, which can be used to model the attack feasibility. But then we see the core difference between the two standards is that 21434 is an engineering standard and common criteria is not. And that has some typical disadvantages. So for example, you will see that verification activities are basically performed on requirements level. And validation activities are only performed on goals and claims level. Like, and sometimes you will just test the entire feature, right? But it doesn't really change the fact that you're not really testing the attack potential. And that basically shows that the attack potential, which you assumed in the original Tara, in the very core of your analysis, is never validated at all. It's usually there's a review that's being done that can be done. Even that can be skipped. You can skip the cybersecurity assessment in the 21434, but that's it. Like it's never actually validated at any point in time. So we are just using half of common criteria for the modeling of the attack feasibility, but we then ignore the second half, which is about evaluating the feasibility of this. So that brings some problems, right? Um, on a normal in a normal automotive environment, how we validate cybersecurity is depending on how mature the organization is. Most of the even smaller suppliers or younger OEMs are able to validate cybersecurity requirements. That is essentially really just functional testing. You basically just have systems engineering that is done in-house, right? Then you have maturity level 2, which is like you're already validating the cybersecurity goals. That is also primarily done in-house. As already said, none of that is actually ensuring any form of coverage, because let's be honest, if you, for example, perform maturity level 2, you try to flash one manipulated firmware onto the ECU, that still doesn't validate that secure flashing is working, right? You have just validated really one scenario that it would actually work. Maturity level 3 then is the penetration testing, which also a lot of companies do. But they often do it in a completely different way, because what they will do is they will do it on component or vehicle level once before the SOP or once before a major delivery. And that's usually then a third-party test, unless the company has pen testing capabilities in-house. So there's absolutely no assurance in a regular development environment that attack potentials are anything more than just guessed numbers. And that leads to a few observations that I've seen, at least in the last 10 years, a lot that are quite noteworthy. Most cybersecurity engineers who make a Tara or any threat analysis do not actually have a penetration testing background, but they have to make feasibility assumptions based on penetration testing. It's really problematic. Then you have testers who test cybersecurity controls, but they also know penetration testers. So they just basically use predefined scripts, right? Or maybe like vector tooling, anything else, right? But they're not penetration testers. So, and then there are actual penetration testers, but how often are they involved? Usually one time before SOP. That's when the penetration testers come. Or even worse, if you have a type approval for a vehicle, you can also just do it once for the type approval of the vehicle. Then the approval authority will do it for you. And then they have some findings, you fix them. So you could even go without the real penetration testers. And there's absolutely no strong feedback loop between what happens in the validation side and in the cybersecurity engineering. So mostly the tests are just there to confirm the functionality. They do not change what the original assumptions were. So after the analysis phase is done, there's often no change to the Tara anymore. And this is actually one of the core problems, because the Tara is a living document, right? And then the last point that we have is that the testing team is very, very careful when it comes to how many responsibilities they are actually willing to take over. I can just tell from like the last 3-4 companies that I've been working with, it's usually problematic to push very cybersecurity intensive tasks into the testing department, because testing departments want to have things that are easy, that are automated, that can be executed also by junior testers. So for example, test suits for SecOC is usually fine if the OEM provides it, for example, but no testing team that I know of will just do like reverse engineering of some firmware, or try to perform power glitching to obtain keys that are hard-coded into the system, right? So that's not going to happen. And there's a few suggestions that I have, and it already brings me to the last part of my presentation, essentially talking about what are some suggestions based on the findings that I've made in the last 10 years, working with the 21434, and especially with the larger automotive threat assessment, which has existed before the 21434, let's be honest. So basically it's 4 of them. One is to close the feedback loop between threat analysis and testing. The second one is to ensure that we cross-skill cybersecurity engineers more into penetration testing, that we stop treating cybersecurity engineers as system engineers that are responsible for cybersecurity. It is a very much a different profession, and that is very much evident if you have people that are working in different domain. They just assume that, oh, if you do cybersecurity engineering, you can also do like, or you could just switch over to safety engineering, or I mean functional development, right? It's very much different from the mindset perspective, and especially from the evaluation perspective. And then you need a stable organizational interface between validation and engineering in this case, because for some domains this is not important. For safety, for example, it's important to, of course, define validation criteria, but there's no feedback loop. Like the original safety assumption usually doesn't change if validation has a test that fails. For cybersecurity, as I just described, that is very much part of the methodology. And then the last point that I would highlight is that we should absolutely work on demystifying penetration testing. Oftentimes, I get a ton of quotes from suppliers, and they treat penetration testing as something completely special, like something that comes from another planet. But it's very important to understand that a lot of things that happen in penetration testing, they can also be done in-house, and they can also be considered part of the regular system testing that is necessary to accept a feature, right? So it's a very common strategy to basically just quote that as a separate effort, even though it's actually it can be expected that you test the security of the system that you deliver in a way. So just going a little bit into the detail, because I think this is quite important, and I want to just elaborate a little bit on what the idea behind this is. As I just explained, there needs to be a feedback loop between the threat analysis, which happens in cybersecurity, and the testing. And as I do it, or as I try to do it in our company at least, is that we want to make sure that the attack steps are more or less translated into test cases, because that way I can actually mimic the preconditions and the steps that are necessary for the test, because that's what I need to do anyways. And then I have a test catalog that is being executed, which when executed is already giving me some feedback about the feasibility of the attack. And that is extremely simple, because I need to specify anyhow for the testing, what is the time, how many testing personnel do I need, how experienced does that need to be, and what is the equipment. All of that needs to be known when I want to perform testing, because I need to order a test bench, I need to get some personnel who does this, right? So I already have this information then, and I just need to use it. And that is essentially the logic behind basically just using the knowledge that comes from testing to adjust the original assumptions that I had in the TARA. In my opinion, this should be part of the process for a release of the TARA, that the cybersecurity the security assumptions that were made about the attack potential are validated by some form of testing at least. A good example for this is, in my opinion, if you have like an engineer that has an assumption while executing the TARA. So he maybe just says, okay, I want to assume that JTAG needs super specialized equipment to access it, right? And then a tester actually finds out that it's extremely easy and can be performed with standard gears. In this case, you can just basically raise the feasibility and adjust the controls, because that might also be an outcome, right? It might be possible that one of the testers finds out, well, it's much easier to actually perform it, and then you can actually change. So this is quite important. This normally does not happen. This is very important. This does not happen, this step. So this is, in my opinion, one of the first things that's quite important. Another one is very much involved to everybody here in this room. I think it's extremely important. We live in an industry where there's so much to learn, and it's really hard. It's really difficult. Like, for example, I'm responsible for a connected system that has cloud in it. It has a diagnostic device in it, which is a PC running regular software on a Windows system, which is connected to an access point, which is connected to the vehicles. and the vehicles as like a clusterfuck of different ECUs, and I have a TCU in there, I have an infotainment unit in there that goes to a different cloud, I have a self-driving system in there which goes to yet another different cloud. So it is extremely difficult to stay up to date in cybersecurity in general, in automotive cybersecurity particularly, right? But I would always say that even though not everybody needs to be a full-fledged penetration tester, it's a really good idea to get some very basic understanding of how penetration testing works and how easy certain things are. It's really valuable, in my opinion, that every engineer has some hands-on experience with just finding out, is it actually so difficult to flash an ECU? Is it so difficult to capture CAN traffic or perform an ISO-TP scan, for example, to find an undocumented interface, right? That's extremely important. So my suggestion for that is really that it's really important to have joint workshops, either with pen testing vendors or with someone from validation team, or combined ideally, and just test whatever you want. Have people understand what the other guys are doing. That might not be so important with all of the other domains, but for cybersecurity, it definitely is. And then personally, what I would also say is that since there's such a variety of topics in cybersecurity, if you have a dedicated team, everybody can more or less just pick also topics that they like and that they're interested in, right? And then you can basically move on from there and actually create a skill matrix, which actually says that, okay, that's the level of skill matrix that we want to have. And that's maybe too high. Like, you don't need to be reverse engineering the cloud infrastructure, but you need to be able at least to see, okay, what's probably the role assessment on Azure Entra ID, for example, if that is actually used in your backend, right? So in my opinion, extremely valuable because it allows people to look into the hands-on aspects and to get a better core understanding. I don't want to have like people sitting in an ivory tower making decisions if they have not touched the bare metal. And then the third point is, in my opinion, that it's a consequence of the first one, that there should be an organizational interface between validation and cybersecurity engineering. So, of course, the first point is more about the process, like how the processes are intertwined. But the organizational interface is mostly about that there are actually roles which you could actually have in your organization that actually take care of this. And in my opinion, this is also how we set it up, that there's offensive cybersecurity engineering, where the focus is less on creating ISO 21434 work products, but more on actually staying up to date with the state of the art of current attacks, right? So it's not someone who's actually it doesn't need to be a penetration tester because it's still in the engineering, but it is a role that is primarily responsible to find out how difficult are certain attacks to be performed, and that serves as an input stakeholder for the testing and validation team. And in the testing and validation team, you also need someone who knows about like general automatable tools and scripts that you can use for cybersecurity validation. So a little bit more than just running a vector test suite, but at least someone who's able to set up, for example, a RESTful simulation, including all of the different ECUs that are necessary for something to validate cybersecurity controls, or who's able to actually build test setups that can actually perform this, right? So that is a really important step. Then we have an my personal view, that is more or less just an organizational measure, but it's really indicative of mature companies that they have this kind of interchange. So that is more or less a prerequisite to reach the goal number one that I suggested first. And then the last and final thing is that, in my opinion, we are too scared of penetration testing. So a lot of people say penetration testing is so complex, we don't do it. I'm gonna like get a contractor, an external company that will do this for me. We will get for some findings and we will fix it. That's fine. But as I just described, we need that kind of competence in-house. It's really not a good idea to have that externally, because that leads to the problem that we have. And also, nowadays at least, there's a lot of solutions on the market that can help you to automate penetration testing, or at least catch the low-hanging fruits. And that would also be my proposal. There's a lot of things you can do on an automation level that is absolutely doable, even in a normal testing team. And this kind of empowerment is absolutely useful because it doesn't mean that you replace external penetration tests, but it means that if you perform an external penetration test, these guys can actually perform valuable insights. So they don't have to bother with the low-hanging fruits because you already have covered them. They can actually dig deep. And then you also already have a structure that you can use to actually include the findings from this third-party penetration test. So you are already set up to understand the problems that the pen testers report to you. Whereas if you have no capabilities and you just say, okay, I give it to someone external, chances are quite high that you have no clue what the findings are about and that you will just fix and patch the things that are broken, but there will be new problems in the future. So it's also not really a sustainable solution. So far for that, I'm quite in time. So thank you for your attendance. Michael, you want to basically grab the mic?
Yeah, thank you very much, Yanis. It was very interesting, and we have plenty of questions. And I have actually one question that comes to my head during our presentation. So I'm totally agree that in-house is very important, but we have like limited budget. And when you're talking about your internal QA testers taking PT capabilities, hiring PT expert, or using automation tool, how you would be balance the budget, the decision in this area?
Primarily between the tooling, you mean, or?
So you have like three options. You have like your the testers that you want to give some penetration testing capabilities. They will be not experts but have some understanding. Hire some penetration tester with good expertise, or buy automating tools and doing PT automated for low-hanging fruits. So where you will be put your prioritization, the focus for the hiring manager?
Oh, okay. So that is quite simple because the first logic should be to have in-house contact persons who are actually able to use whatever input comes. And then, so without having someone in-house who understands it, also very hard to automate. You can always just automate what you understand, right? So there's no shortcut. So you have to have first at least a good understanding what you actually want to do, and that requires you to have the people first. Then you need to qualify these people, of course, in a way. And then the next thing, and this is, so I would say like 50% would be on getting the right people on board. And then the other 50% is essentially like having penetration tests externally is quite valuable, but then you need to actually be able to incorporate the findings. And that requires that you have a test landscape set up. So that is the automation part. So in my opinion, there's a clear priority, get the people, automate, and then you can have a penetration test, and then you can actually work with the results.
Excellent. Thank you very much. So we'll start taking questions by question from the audience. So in automotive, which attack vectors are usually overlooked by Tara?
So the attack vectors, I'm assuming that attack vector really just meaning what kind of attack that we don't really assume is possible, right? One is most overlooked. One is actually like side channel attacks, because side channel attacks are a pain in the ass. You can ask the guys from penetration testing companies about this. You cannot really defend very well against side channel attacks unless you perform lockstep or something else. And you can look on the market how many HSMs there are with lockstep. It's not a lot. So these kind of attacks, you can consider them in the Tara, but you cannot do a lot about it. So often these are completely ignored. So I've not seen a lot of Taras that actually mention side channel attacks. The risk is there, but you can rarely do something against it. The only mitigation is don't use fleet keys, because if you use fleet keys, then it is a larger problem. But there's not a lot you can do here. So it's one of the topics that is basically ignored, even though it's very much practical.
Thank you. Next one. What would you recommend to someone who is quite new into cybersecurity to gain experience to evaluate a stable Tara or attack paths in general? Is it necessary to become a hacker?
Absolutely, yes. You need to be a hacker. At least you need to have the hacker mindset, right? So if you want to go in cybersecurity and you want to just fill out documents, then it's not the right job. I think it's a good idea to at least acquire a hacker mindset before going into cybersecurity, and just be curious. Build your own projects. There's a lot of cool stuff nowadays on the market. I would personally like build my own portfolio. When I started in cybersecurity, I was just participating in capture the flag contests and hackathons and all of this kind of stuff. That is not really professional, but it still adds up a lot of knowledge. If you're very new, if you want to know, like, you can also just get the standard, right? But I would say that if you're very new to the industry, just pick a topic that you really like, that motivates you, that where you can actually think, I'm still working in this for 10 years. Because if you just download the ISO 21434, I can promise you, you will be super demotivated before you even start your career in cybersecurity. So definitely start with the technical stuff and start with the cool stuff.
Yeah, but the cool stuff is coming in the app. So you have like Tara
Yeah.
V model, a lot of documentation, a lot of boring stuff. Only in the app you have the cool hacker stuff. It's also
Exactly.
to be clear.
Exactly.
Okay. Would you also say the three different rating methods can be used at the different phases of the development lifecycle? So you maybe use a attack vector-based approach during an early concept because the system is still very vague.
Very vague. Yeah. Yes. So in a way, but it's still difficult. So for example, if you use CVSS in the first sketch, and then later you get the results, but then you switch over to attack potential, it will be really difficult because you cannot really transfer the results then. It's easier to pick one and stick with it. And if you use CVSS, you can also do that, and you can apply the same logic, by the way, and then validate the CVSS rating later. But I would stick with one methodology.
Thank you. Next one, what are the most important factors that prevent organization from adopting a realistic approach like this? I suppose it's like implementing penetration testing inside the organization.
Yeah, but this
Probably.
is one of the points. I'm not advocating for like let's everybody like build a huge penetration testing within a team within all organizations. That's not economically feasible. It's really just about the priorities. And if you have for example, a small organization where you don't have a lot of money. I mean, I'm in a company that has 200 people, so it's not huge either, right? So you can always it's mostly a question of prioritization. And if you say that you have budget, for example, then don't spend your entire budget on external penetration tests and then call it a day, because that is not a sustainable way unless you just want to release one vehicle and then vanish from the market. If you want to have a long lasting impact, then you just need to approach that kind of strategy and build something in-house that lasts, and then spice it up, then add the external support that you need and the experts that you need to have a lasting effect. So what prevents this approach is actually mostly the understanding of how necessary this is, because this is only true for cybersecurity. For a lot of other domains, this is actually not the case. So for example, for safety, you would not need that kind of a feedback loop between testing and validation. You would not need a specialized, like, I don't know, offensive safety engineer doesn't exist. So you don't really have these kind of roles, right? Because the scenario doesn't exist. It's mostly an awareness topic where people just hear cybersecurity and they just don't understand properly what's going on. But the guys who make these kind of decisions, organizational decisions, they usually have never heard about the content of the Tara. They've never heard about the 21434 and definitely not about common criteria.
And usually they're leading full departments responsible for it.
Yeah, exactly.
Thank you very much, Yanis. It was very interesting discussion. We have a huge amount of questions. Yanis will wait you in the lounge. We're out of time. So again, thank you very much. It was very interesting, and you are welcome to join us in the lounge. Thank you, and have a good day.
Thanks to you guys.